Hey there. So, tonight we're going to talk about gold nuggets versus water. The question that I got asked, I've done a little query recently. If you're on my newsletter, you're going to get an email that asks you to kind of give me a comment about what you'd like to see more videos about on here on Facebook and on YouTube. And so one of the responses I got was kind of interesting, pretty simple one. Basically stating, let me pull it up here on my screen so I can read it to you. Hi Jess, would like to see an explanation of different mats for sluices. Paul. Okay. Pretty simple question, right? But not really. And I'm going to explain a little bit tonight about why it's not that easy to answer, but why it's important. The answer itself is very important for you to understand if you're going after placer gold nuggets. Okay? And so it's going to be a real brief intro to this topic, because this topic, well, I spent a fair amount of my degree on just this thing called fluid dynamics. And so what I wanted to kind of poke at a bit is kind of why it's important, and also why it's complicated. Why it's important, why it's complicated. When you're looking for gold, you've probably heard or may soon hear somebody tell you that it's all about pressure. Gold likes to settle in areas, having to do with low pressure, high pressure, etc. Okay, well, it's kind of some truth to that. But in reality, it's all about velocity, the dynamic of the flow. And dynamics means it's in motion. Okay, so keep that in mind when you hear dynamics. Don't think, all that, that's highfalutin stuff. Now, it's simple. The water's moving. In fact, it's flooding. And so the gold doesn't move if the water's static. That's called hydrostatics. This is hydrodynamics or fluid dynamics. Okay, it's in motion. That's what a dynamo does. Okay, so here's the thought. If you can visually understand in your brain what happens when the water you're looking at, which by the way typically isn't there, hopefully, when you go out and prospect, it's gone for the season. Okay, don't go out there in the flood season, and don't go out there in the monsoons in summer out in the desert here in Nevada and Arizona and California. You can run into some serious hazards if you get into that hydrodynamic situation when it's a flash flood. When there's a storm over the horizon uphill from you, that's danger. Okay, so here's the deal. That water moves, and it carries with it kind of two concepts. One is kind of the energy stored in the mass of flow itself, which isn't just water. That's part of the deal. It carries with it a suspended payload, slurry, mud, rock, silt, boulders, okay, cactus, cars, and so on. And so what you're trying to do here is understand the dynamics of that motion and its impact on gold. Now, what I said earlier is the gold really depends on the velocity, and that has to do with the thing called friction. So tonight we're just going to kind of introduce some of these topics and go after this thing that was asked, which is the explanation for different mats. That's beyond tonight's subject. I'm not going to go into mats yet, but here's the deal. Mats are a fluid dynamic instrument, okay? And if you start to see them that way and start to see your floods and your rivers that way, you're going to start using your head as a new computer gold finding device on par, here's the deal, on par or beyond the best metal detector out there. Huh? Yep. You're going to be able to see things that normally would pass by a detector, because it's not looking for the terrain or the effects of water flow. It's looking for metal. Okay? That's all it's looking for. What you're looking for is, well, where should I probe for metal? Okay, see the difference? A little subtle, but a very important distinction. And specifically, where should I probe for things that would be waterborne placer deposits that are broken off from old lode and distributed by water downstream down to bedrock? Gold flows downhill, downstream, down to bedrock. PJ's rule. So let's go after it, okay? We are talking about things like airfoils. So in this case, you can kind of see what happens here. It's interesting that we have this flow going over this surface. And you notice the kind of idea here is that the flow is slowing down here, and the pressure here increases to give it lift, okay? It's speeding up over the top. Well, we've all heard of this Bernoulli kind of thing. And so what happens is, that is one of the effects you want to kind of keep in mind when you're looking at the flow for gold. Now, here's why, and it's not what you think, because a lot of people will say, well, you know, you want to pay attention to where the pressure is. And the answer, well, actually, you want to pay attention to where the slow speed is. Why? Because it's the speed. Remember we talked about that flow over a surface breaking loose and decreasing friction? Okay. Well, what we want is basically to somehow cause this thing to break loose from the frictional forces. Well, those frictional forces are caused by the speed of the water and its viscosity on the surface and the shape of the object. So if the water is zipping across this rock containing gold, it will move along because of the drag on the surface. That's friction. Okay, that's what drag is. When it slows down, like in this area you see right here, I'm going to circle it in red, okay, then all of a sudden this thing doesn't have enough drag or friction to keep it moving along, and gravity gets to take over to bedrock, okay? And that's really what tonight's about. It's that simple, but it's the velocity. It's the speed at which the flow moves. So now when you're looking for places where gold would hide, you're looking for places that slow the water down in high flood. So here's the deal. The simpler the flow, the more friction, and friction carries your object downstream better than anything else, so it's the speed of the water at that point until you hit that turbulent point. And then things start reducing friction, and that means it means more speed if it's turbulent. It needs even more speed. Now, where have we seen that before? Flash floods, massive turbulent floods moving masses of rocks and cobbles, that's all turbulence. Anytime you see whirlpools and swirlies and stuff like that, it's all turbulence, okay? I mean, the kind that have just constant flow, bottom of a waterfall, it's all turbulent flow, okay? So you can kind of see now, at the top of the waterfall, when it's just heading over the lip, nice and glassy and smooth, laminar, okay? Laminar flow has a real good traction on whatever it is going over the edge. But once it hits the bottom and hits all that turbulent stuff, it'll tend to drop stuff until the actual impact of the flow, that gets into the mass thing I was talking about. And that can redistribute your gold, also can cause rocks to smash into your gold and fragment it, and releasing small little powder flour stuff. So it's not uncommon for, if there is any gold trapped at the bottom of a waterfall, if it polishes out, it's powder. It's going downstream as flour, and it'll go down even in laminar, even in still flow. It'll take a stagnant pool to make the gold drop out into little tiny flour gold, sandbars, okay, and clay deposits. And that's pretty much it for tonight. So, gold nuggets versus water, who wins? Comment below and let me know what you say. I want to hear from you. It was great. We've gotten a bunch of emails back on that topic of, basically asking people what videos and content would help more. And I'm willing to listen to this one on this guy. I'm always willing to listen because, you guys are great. And take care, good prospecting, and good night. Bye-bye.